Good morning, students. Today we'll be learning about electrical machines. What are the requirements of these electrical machines and all. First of all, welcome to the DAD Institute of Engineering and Technology. So we'll be learning about all these electrical machines. So welcome to the online class of Electrical Machines 1 by Mr. Ravi Kumar, working as an assistant professor in the DAD Institute of Engineering and Technology. So coming to the learning objectives is understand the construction and principle of operation of DC machines, learn the characteristics of performance, methods of speed control and testing of DC motors, and to predetermine the performance of all these machines. Coming to the basic concepts of electrical engineering, we need to know all these. What do you mean by charge, and when can you say that the body is charged, and what are the different types of charges, and what is electricity, what is voltage, what is current, what is resistance? We need to know all this before going to learn about the DC machines or electrical machines. Coming to the charge, it is a physical quantity of matter that experiences a force when placed in an electromagnetic field. There are two types of electric charges. One is positively charged particle and the other one is negatively charged particle, commonly known as electrons and protons. These like charges repel each other and unlike charges attract each other. This is one of the phenomena of these charges. And coming to the charged bodies, when can you say that the body is charged or not? If there are excess of electrons, then it can be said that it is a negatively charged particle. And if it is having less number of electrons, then the body is said to be positively charged body. Either the charged body depends on either having excess or lack of electrons. Based on this, you can say whether the body is charged or not. If they are having equal number of electrons and protons, then it is a neutral body. There will not be any charge present. Coming to the electricity, it is nothing but the flow of tiny particles called electrons and protons. It can be also mean that when electrons flow from one place to the other place, it can power up certain electrical equipments like bulbs, fans, lights, computers, etc. Today, electrical energy is being the most useful and most reliable form of energy because this form of energy can be converted into various other forms of energy. Coming to the voltage, it is nothing but the pressure from an electrical circuit which forces the electrons to move from one place to the other place. By doing so, we will be doing some work, which is nothing but the voltage. It is because of this voltage only the current, because of this pressure, the current will be flowing in a conductor. Next, what is current? When force is applied, there exists um, some type of reaction on a particular body. That when force is applied on electrons, the electrons move from one place to other place, and a current will be flowing. Current will be produced. Current is nothing but rate of flow of charge. The force which is responsible for that flow of current is nothing but voltage. And here, due to the flow of electrons or charge, when they are moving from one place to the other place, then current is said to be flowing. If you clearly observe this one, this gives the clear view of voltage, current, and resistance. See here, water will be having at some particular height. When it is at some particular height, can be treated as the voltage, because it will be having some force because of the gravitational force. Here, if you are having a pipe, based on the adjustment of the valve, the flow of water from here occurs. Here it is having some energy. This water is having some energy. When you are adjusting the valve, is nothing but a resistance. That adjustment of valve can be treated as a resistance, and the flow of water from here is called as current. Can be treated as current. According to Ohm's law, V is equal to IR, or I proportional to V, where R is the resistance of the particular element, V is the voltage, and I is the current. See, this gives the clear example of voltage and current and resistance. See, voltage is nothing the force which is applying for the electrons to flow, which is nothing but the current, and resistance is nothing but the opposition being opposition offered by the particular element to the flow of current. See, Oersted has done one experiment, and by mistake he has found that when current is flowing in a conductor, magnetic field is produced around that conductor. While doing his experiment on a bare wire, by mistake a magnetic compass is within that under the bare wire. When he is doing some experiment, when current is flowing in a conductor, he observed that magnetic compass is being deflected in one particular direction. And he further done the experiment by reversing the direction of current. And he observed that when the direction of current is being reversed, what happens is the flow of the production of magnetic field direction also has been reversed. From this, he has concluded that when current is flowing in a conductor, magnetic field is produced around that conductor, and the direction depends on the direction of current. See, coming to the fields, we are having two types of fields. One is electric field and the other one is magnetic field. Coming to the electric field, we need to know what is electric flux, electric field intensity, electric flux density. Electric flux is nothing but the total number of electric lines of force present in a particular area. The total number of electric lines of force is nothing but electric flux. Electric field is nothing but it is the region around a charged particle over which the force would be exerted on the other charged particles or objects. Electric field intensity is nothing but a point at a particular point if the force is experienced by a particular unit positive charge. If a force is experienced by a unit positive charge at that particular point, that particular area is called as electric field intensity. How much amount of force with which it is experiencing a force is called as electric field intensity. Next is magnetic flux. Same as electric flux, here also the total number of magnetic lines of force present is nothing but magnetic flux. Magnetic field, the region around that particular magnet where the force of the magnet acts, with which it can attract or repel the other magnet, is called as magnetic field. Next, magnetic field intensity. It is nothing but the force which is experienced by a unit north pole placed at a particular point. Next, coming to the Faraday's laws of electromagnetic induction. Faraday has given two laws based on which we can say that in how an EMF is induced and what is the value of EMF induced in a particular conductor. According to Faraday's first law, whenever a conductor cuts the magnetic lines of force, an EMF is produced around that particular conductor, in that particular conductor. And according to his second law, the magnitude of induced EMF is directly proportional to the rate of change of flux linkages. It is because of this scientist we have uh, different motors, generators, transformers. Next, what is an induced EMF? An EMF is said to be induced when flux linking with a coil changes. Next, the change in the flux can be obtained in two ways. One is by statical method and the other one is by dynamical method. In statical method, there is no moving part, whereas in dynamic, there is a moving part. Based on the types of induced EMF, we can say that they are of different, they are classified into different types. One is induced EMF is classified into statically induced EMF and dynamically induced EMF. The statically induced EMF is again subdivided into self-induced EMF and mutually induced EMF. Coming to the statically induced EMF, this type of EMF is generated by keeping both the coil and magnetic field as stationary at the same time, which means that the change in the flux linking with the coil takes place either without moving the conductor or the magnetic field. It is again subdivided into two types. One is self-induced EMF and the other one is mutually induced EMF. The EMF, self-induced EMF, is the EMF which is induced in the coil due to the change of flux in the same coil which is linking with it. Whereas mutually induced EMF is EMF induced in the coil due to the change of flux produced by another coil which is linking with it. Dynamically induced EMF. In dynamically induced EMF, either the magnetic field or the conductor should be moving. Any of them should be moving. Here there exists some moving part.